Hello folks, how are you doing? This isn't one of my normal streams. Hopefully this is working. Let me just look across and see if everything looks okay. It does. This is going to be a bit of a repair live stream, and the reason for that is I've got some stuff that's come in to repair which is quite interesting, and I thought I'd do it live. I've got tons of content I should be making, but I can't be bothered. I've lost the will to live with regards to making content at the moment. I've lost my mojo, to say the least, so I fancy doing a bit of a stream, and we'll take a look at what's in front of me, and I'll share with you guys up front now what that is in front of me. One moment, let me get my button and go to the overhead and let me find it, and that is, if we come out here, we have an Avatar VTX for the Avatar HD system from Walksnail / CaddX. And in fact, we have two. We don't have one, we have two. And we have two with two separate issues. And what we're going to do today is we're going to try and get one of them working. Now, I'm going to explain what the faults are on these two VTXs first of all, and then we'll take a look at what it takes to actually get one of them up and running. Hopefully we can get one of them up and running, because we only actually have parts for one of them. Well, we're going to nick parts off one of them for one of them. Now, it's great to see everyone in the chat. I'm just looking back across. Hello. Hello, Sean. How are you? Hope you're well. Good evening, everyone. I hope everyone is well. Expander. Everyone else, I'm not going to go through everyone's name, but so, okay. We're going to take a look at what the two VTXs are and the faults on them. Now, this VTX quite clearly has a missing connector. We've taken the heatsink off just to have a quick look. The reported issue is that it won't power up now, but the connector's been ripped off. The gentleman, I believe, has tried to do a bit of a repair, but he couldn't get it working, and it is now apparently showing as dead. Now, I also believe he borrowed that regulator, which is down there, to try it on this one, because this one had a blown power regulator. In fact, if you look here on the cover for it, you can see that there's a burn mark, and the regulator is actually missing off this one. Let me find where it actually should be. Where's it gone? There it is. Sorry, the on the board is where the regulator should be. If I get in a bit closer so you guys can see, there we go. That's where the 5-volt regulator should be, going into the coil and out from there. And he's already removed it. And I believe he tried to do a repair on it already, although I have seen a few things that may have caused it not to work. Now, if we do just go in closer, it is clear that where this regulator went, it has burnt the track a little bit, but it's nothing phenomenal. It all looks fine. If we get the multimeter on it, from the coil, from the inductor, so if I just pop that there, if I just go down, I want to, actually, if I go this side, there, actually, this is totally my wrong hand. So let me just get this where it should be. That one there, that one there. Yeah, there you go. You're getting the beeps. So that's absolutely fine. Now, what I'm actually tempted to do on this is, we won't start with the one with the broken connector, because whilst that seems the simplest to fix, I'm interested in seeing if this one is actually alive if we nick the regulator off it. Now, we did try, but this regulator is currently shorted out, so I want to get this one off the board and give it a shot. Now, I am not using the normal cameras. I'm on a webcam for this one rather than it being a proper camera, so I do apologize for the lack of the usual quality, and I haven't got my usual lighting set up either. So what we're going to do is we're going to lift the regulator off the one board, we'll shift it over, and we'll have a talk at the same time. I hope everyone's had a good week. I'm just going to move the live chat a minute just so I can see it a little bit better. I'm going to put that there so I can actually see it. Good morning from New Zealand. How are you, my friend? That is tiny soldering. Yes, it is. Yes, it is going to be indeed. So we'll get back on the overhead. I'm going to move that nice and high so I can actually see what's going on that one there too. So what we'll do is we'll get this first regulator off. I hope everyone's had a better week than me. My week has been frankly shite, if I'm honest. Let me just make sure that's nice and focused. Oh, my phone is going nuts at the same time. The gentleman. Oh no, sorry. Someone I was answering a question to was responding. So what we're going to do is get this regulator off first of all. We're going to use some heat to do that. So we're going to get the flux. We all like lots of flux. I tend to use this thick stuff. I like this stuff because it's thick, it's goopy, and it doesn't run away from me. I'm just going to try and find the proper tweezers that I should be using for this. Oh, they're missing. My repair bench is an absolute crap tip at the moment. If I could show you it, you would be shocked how bad it is. So what we'll do is we'll use this one here. We'll use these tweezers for this. We need a bit of weight as well to stop it rocking away. So I'm going to get the hot air on. Damn my gun, turning the heat off. So we're going to just lift him off. I'm going to put a bit of heat on him and then get him out the way. There we go. Pop him down there, out the way nice and safely. And pop him off the board. Now, the first thing we need to do is actually, we'll wait for that to go quiet as well. We're going to need to make sure we get this on the right way. So, I'm going to go on my desktop. Let me just bring up my browser window for you guys as well a minute. And go to the desktop. I here am on repair.wiki. Go away, Steam Deck. Don't need you updated right now. Repair.wiki is where I've been uploading images for the avatar system and the boards. And on here we have images of the PCBs. And I'm going to use this just to try and check which way round the regulator should be. That's not very helpful because I can't see the writing on the chip. So that's not very helpful to us, is it? Let me just come back to the clean. So we now need to figure out which way round it should be on this new one. I've definitely had better pictures than that. Let me just look on my phone a minute. One of my lights just gone off. It's got very dark in here. Let me just check. There's definitely been better images than I've shown there of the regulator on these. In fact, I should have better images on my phone. I tell you why, because I took some a little while ago for use, trying to identify it for people. I think I put a picture of it on Twitter, in fact, if I'm honest. Let me just tilt that down a little bit. That looks way too high. That's better. So let me just go on my phone and have a look. And look down the list. Not that one, not that one. I might be better looking on Twitter, actually, because I think I put the picture on Twitter. Oh, I tell you where I did put the picture. I definitely put it on Twitter, but I also put it on the EEV blog group as well, because I was trying to find what the unit was. Tweets and replies. So what we'll do is we'll have a look on Twitter. There we go. Sorted. So looking at it that way, HA needs to go upside down. So if we go back to the overhead and find where we want to be. So we want down here is what we want to repair. So we want some flux before we do anything. What we're also going to do then is probably do this by hand, if I'm honest, this repair. We used air to get it off, but there's not really any solder on those pads. So I'm probably going to do this repair by hand. Now the direction this one goes is that way there, as I understand it. So what I think we'll do is we'll tag it down manually first. Come on, go where I want you to go a minute. There we go. So let me get the iron out. And I think we'll do this by hand with a bit of leaded solder. That'll just be a bit easier to do. I'm going to put a bit of solder on the iron. And then what I'm going to do is just put a bit of pressure on the chip so it doesn't wander off. Minute. We'll tag it down. Here we go. That's that side. And then we'll bring this side round rather than do this with the... I'll tidy it all up in a minute. At the moment, I just want to get it on there. There we go. Okay. So, we've got it on there now, so I'm not going to worry about that a sec. So what we'll do is get it tidied up. I will come back to the chat now in a second, guys. We'll just get that tidied up and make sure I've got it the right way round. Isopropyl alcohol to clean the board. I should have cleaned the pads, really, but I was being lazy. Now we can see the labeling on that chip nicely. Now I've cleaned that. That'll be fine. I just want to look at that compared to my image just to check I have got it the right way round, and then we'll see. Yeah, H. Yep, there we go. Perfect. So what we'll do now is we'll do a quick test and just see if this one powers up, because if that one powers up, that's a quick fix on that regulator. I've seen OpenEye FPV. I've seen people use liquid solder and then use the hot gun. Yeah, it will work. It has to be very clean. It has to be very clean pads. You know, that's not as nice as I would like it. If I wanted it perfect, what we could do is just reflux it, just so there was plenty on there. And if I want to be pedantic, we can come in with the hot air. And reflow that way. But there's not a great need for that on this. There's a bit that way. We know it's on. It's fine. It's fine. So what we'll do is just get this cooling. I do keep a bench fan for cooling stuff like this. We don't want things taking too long to cool down, so I do have a bench power supply here, which I'll fire up now when it wakes up. It's a bit slow to boot, takes about 20 seconds. But yeah, we have a little fan, we blow over it. It's a PC fan on an XT60, so it's just good for cooling things down. Will I put it on an antenna on it? Yeah, we'll put an antenna on him. What I'll do very quickly is see if it powers up. I'm not particularly concerned about blowing it. As for the cause on these, the gentleman had two fail. He had one with the connector come off and then died. And then this one. I don't know the in and out cause. Everything 100%. Just give that a good clean. Brush and isopropyl alcohol are always my two favourite things. There we go. So what we'll do first of all is we'll power this up and see if it comes on. Very quick, power on, power off. Not going to worry about antennas. I do have antennas here, but for a quick power up, I'm not concerned. These power amplifiers will survive fine. I've got no concerns about them at all. I have got two antennas here, which I can put on, but I don't want to waste the UFLs You only get so many connection cycles on a UFL, so you don't want to waste them. You want to make sure that you only get like 20 cycles on a UFL, so you don't want to be putting it not to good use. So we have an avatar power cable off of VTX. What I don't know is if it'll actually light up if there's no camera attached. We'll give it a shot. Okay, so my bench supply, I need to get that connected up. Where is the piece I'm waiting for? Here it is. It's not as long as it should be today. So 1, 2. And what we're going to do is power the VTX up. We'll give it 15 volts, and what we'll just see is if we get any life off it. I'll go back to the overhead now so you guys can see what's going on. Okay, so I'll go back to the scope. It's not easy on the scope for you guys to see, but all I'm going to be doing is looking for if there's any signs of life. Where's the LED on this board again? It's on the side somewhere. The LED must be this side. Where is she? Ah, she's over there. There we go. So we'll just keep an eye on that a second. So we'll go for it. Just going to power down and power back up. So let's have a look. Okay, it's drawing 0.07 of an amp. If there's no camera attached, it's unlikely to power up as well. What I think we will do is let's go on DC mode and let's do a DC check on the output of this regulator. So we'll power it up, taking 0.7 of an amp. And I think what we'll do is we will check under the microscope what we are getting from this regulator. So yeah, that's not good. That's certainly not good. We should be getting 5 volt here, and we're not. I would guess that regulator would power up without a camera. Let me just double check that that is ground. Just we'll come to here and here. Yeah, 15.9 volts, that's fine. Yeah, there's no voltage. So it looks like this reg has failed as well. The output pin, it's not the right angle for my hands, this, but the output pin on this is this pin here. Yeah, we're getting no voltage on him. We've got, just get the angle right. That pin, let's just check which is what we're getting on you. 15 volt there. Yeah, it's not looking good. 1.9 volt there. Okay. 3 volt there. Okay. 4.89 there. That's interesting. Is that, yeah, that's not the output off the top of my head. Okay, let me just rotate this. It's not the right way for me a minute, so I can check on the other side. Let's just look at this board. Let's just look at the pin out for this regulator again, just so we're not going mad. Just go under this one. Oh, we're going to want to clean that so we can see. Okay. Let's get that one a minute, just so we can see. Right, so you can see the output pin is the middle pin. The output is definitely middle. So if we just go on continuity, we'll follow it round a sec on this one. We'll power that one off. So what we've definitely got is output there, because you can see a big pad going from there across, and that should go to there. There we go. I suspect that's ground. Yes, it is. And that's volt in, and I suspect that's power in. So in, out, ground. Okay. Yeah, so that goes to the coil. So on the pin out, we've got them there. what we'll do is we'll do some basic tests. So we'll go on the output first of all and look if it's shorted. Yes, it is. Dead shorted on the output. Dead short. Okay. So we need to know, is the short on the regulator or the board? So we're going to have to get that back off and then have a look. So we can pull the plug on that. Let's get the regulator back off. There we go. Okay, and now we'll do is, sorry, the gun goes very loud. And then what we'll do now is we'll do a short check. So what we want to now see is if the output is still shorted. So we've got ground here. Ooh. Ooh, yes. This one is shorted nicely. Okay, so there's a short on the output of this, so that short should be at the coil as well. So if we go to the coil, board is hot. Yes, properly shorted. Ooh, this is a good one. I likes this. Okay, so I need some more isopropyl alcohol. Let me get my camera. So we've got a short. Thought I saw a spark a few minutes ago. You may have. Perhaps you did. When I fired it up, do you mean? I'd have to go back and watch the stream. Let me just get isopropyl. So the nice thing now is we get to find where the short is. That's always a bit of fun. That's always a bit of fun. Let's have a... There's nothing visually on this board. Ow, ow. Ow, it's hot. She be warm. Let's get the power supply back on and cool it. Second. Ah, did you see a spark? I was looking at... Let's cool it a minute first. There we go. That's a bit better. We're going to have to get this bloody compound off it as well, because it goes everywhere. Oh, we don't want it on the MIPI connector. Too late. We'll deal with that in a minute. Okay. So, let's go back to the overhead and let's start looking. So, we've got a short on this board. So, what we want to start doing is trying to understand where the... Oh, God. Look at that. Compound is going everywhere. Sorry, let me just clean this off. Does my nut in. Right. Okay. So we want to start looking at where the short could be. Now, there are several ways of doing this on a board like this. We're going to check it's definitely shorted. So that's... definitely shorted. So that's ground, shorted, input. We've got a cap here, right? Interestingly, could be this cap. Okay, on him. And he's shorted too. Now these two here could be suspicious. So something we could do is just try taking him off and seeing if it's him. Let's just have a look around closer first of all. I'll get up to the mains. Yeah, Bruce. Let's just have a look that there isn't anything going on. Everything looks fine. But what you could have is a short on the regulation anywhere else on the board. Yeah, nothing looks bad there. Yeah, no, certainly nothing looks terrible. So, what we'll do is we'll go for the old power supply method. Now, what the power supply method is we'll hook up voltage to it. Very low voltage. So we're going to solder on some wires first. So we're going to get a ground in place. And we know where the ground goes because that just goes there. But we could also solder the ground to here. So yeah, let's tag the ground on over here out of the way. There we go. Then we'll solder on a positive. 2 seconds. There we go. Right, so we then want probably what we want on that one there. Want to keep away from this. We want to be oh, that pad. Look at that pad. We're not going on to that. That pad is moving. Wow. Okay, we want to be on here then. Because that pad is moving. I think what we'll do, let me just get that in the way. The pad is moving around a bit. So I think what we'll do, sorry, what's happening now is the wire is dragging the board around. We'll go on this side of the coil. I think we'll go on that side of the coil. Oh, that track actually. I scratched that up a bit. We can go on there. If we just go here, we need to clean this. Let's clean some of this off here. There we go. And then we'll go on to there. You can see that track is definitely lifting. We can repair that. That's not an issue. Yeah, I haven't got I've got some below, Bruce, but I'm getting lazy. I could pop down under the table. I've got like a reel of it. I nicked it off a motor. You know what it's like. There we go. Sorted. Nice big bobble there. There we go. Cool. So what we're going to do is we're going to put some voltage into this, but we're going to put it in at very, very low voltage. So what I'm going to do is set my power supply at about 1 volt. Let me just go onto the preset. And I'm going to set the current limit at 1 amp. 1 volt, 1 amp. And then what we'll do is start to increase the voltage. Oh, I see the pawn is back. And then we'll increase the voltage as we come up. So we need to not use a short saver for this because we don't want it. I just need to get an adapter because my short saver acts as my XD30 adapter for my power supply as well. And we definitely don't want a short saver on it. It's not going to help us at all. Let me just see. I had them in my hand yesterday. They're over here somewhere. Let me just find where they have vanished to. It's always the same, isn't it? You have something, you are playing with it, and then you need it, and it vanishes. Why have they gone? Why? Just checking in my XT60 box. No. Oh, this is ridiculous. I literally was using them yesterday. Literally was playing with them yesterday. The chances are they're on the bed. Ah, there they are. Being blind, I stacked them all up. Okay. So we want you to you to you. There we go. So what we're going to do is put voltage in the board and see what gets hot. That's the basic premise of this, and then up the current until something gets so hot we figure out where it is. So I'm going to zoom out. So as I've said, power supply is set. So at the moment we're drawing 0.75 volt at 1 amp. So what I'm going to do is just get some isopropyl alcohol and just start putting it around the board and just try and see what gets hot. Because at 1 amp, something should start to cook. Let's get a bit more into it. Right. Now we're driving it in. 1.5 amp. Something should start to get toasty. Ow. Oh, it's definitely hot around this side of the board. Ooh. Ooh, yes. It's very hot. I wonder if it's that IC. Oh. This is where I do wish I had a thermal camera. This is one of those FPGAs, look, on this one. This is where I wish I had a thermal camera, because it would make a big difference. Right, we're going to drop a bit more current in now. We're dropping in 2.5 amp. Something is going to get hot. At 2.5 amp, something is going to get very hot very quickly. I think it's that IC, look. Look how fast that is flashing off. That is just rocketing. Is there anything over this side of the board that could be doing it? Let's just have a look. Ow. It's never easy this way. It really, really isn't. Get on your phone. Get one on my phone. Yeah, I definitely need to. The coil's getting hot, that's for sure. So this, right? I might lift that cap. I might be tempted to lift that cap. Because that cap is getting hot. Should we lift him? We're in a low lose situation at this point. So I think we're going to take that one out and just see. And we'll see if the short is still there. I'm going to just undo the wiring. If it is, I suspect it's an IC issue. But we will lift that cap down there. Just because I'm a little bit suspicious of him. I don't know why. It is all getting hot, and this is where it's hard without a thermal camera. A thermal camera will show you it instantly. But if we do have a dead one, right, we may have the ability to actually decase. Okay. I'm also... Cool. So he's off. Let's see if the short is still there. Yep. Okay, so at this point, I think on this board... You're right to be suspicious. That cap's eyes are far too close together. What's the thermal camera cost? There's some good electronic board ones now available for like $300-400. I think it was when I was looking last. There's one out there. No, an IR camera wouldn't be enough. Yeah, a thermal camera on a board like this is thing. Someone said you should consult Lewis. The trick that Lewis has is, Lewis is so good because of he's learned the maps inside out. They know the circuit they're working on just inside out. And if you notice with Lewis, he sticks very much in the wheelhouse that he knows. He knows all of the PP buses on the MacBooks. He knows how the power stages work and everything. And when you know that, you're able to follow diagnostics down. And you can do that when you've got access to circuit diagrams and everything like that. Because we don't have this, you are somewhat pissing into the wind because you don't have a path to follow. You don't have the logical steps of, okay, the regulation comes in, you should have 12 volts there, 5 volts there, 3 volts there, 1.8 volts there. So you're left in a position that it's very hard to diagnose on something where you don't have this stuff. And that's why generic board repair is quite difficult, but it is doable when you have things like a thermal camera. If you watch the likes of Bridge Fix, he's really good at repairing anything. You know, he'll go in, put it on power, get the thermal camera on, and get it up and running. I'm just waiting for the board to cool. So it is quite hard when you don't have access to those things. You need, and it's really hard to reverse engineer in a circuit like this. We can have an idea of what's going on, but you don't know the full layout. We learned a lot about HDZero actually, but it takes time. I have done it with the with the HDZero VTX. I learned a lot more about that, and we'll learn about the Avatar one as we move through. There are thermals. If I hop over to the desktop a minute, there are thermal cameras out there, and there's some really good ones actually. Let me just open a new browser window for you guys. I go to the desktop. If we go to, not Banggood, if we go to AliExpress, and if we just search for PCB thermal camera, there's some really good ones out there that have seen some good reviews. Let me just find the one I'd seen. These ones have had some decent reviews. About $500. Now these aren't portable thermal cameras. These are desktop thermal imagers. They do now make one for the phone, look. That's interesting. $242. It's not bad at all. Don't know what's the imaging like on that. Let's have a look. Okay, look, they're saying, what's the resolution though? Android Type-C connector, which means I could use it on my tablet. They have an app. Do you know what? that I'd be tempted on looking at to see what it's like. Is there a review of that? That looks pretty good, to be fair. Has anyone reviewed the phone one? No, it doesn't look like it. A lot of people have reviewed their desktop ones, and their desktop ones are okay. But there doesn't seem to be infrared eye. There doesn't seem to be reviews of it. They have their desktop ones here, which there's been reviews on. Oh, let me just pause music and let me just go through you, and then you'll be able to see what he's seeing. Like under that one there. There you go. That gives you an idea of how those other ones work. They give you like a PC app, and you can have a look from there. But they're not high resolution at all. They're really not. Let me just get the screen back up. Oh, let me just also get my chat, because I cannot see you lovely people. Black and white image over the top. Heat sensitive paper. It's really hard. It all flew a couple of... Plastic. Yeah, there's some good flares out there. Those Quinali... Ah, yeah, there you go. The gentleman, Jossie, mentioned it. Yeah, they're pretty good, but they won't. So, I think what we'll do... Let me get back on the overhead. This one we know is going to be a play for another day, in the sense of... We know there's more going on here. We'll probably come back to this one in a minute. And what we can do is we'll poach the connector off this one, because we can always power this one manually, and get this other board powered up. But I won't use the connection first of all, I'll wire it. So what we'll do is we'll get the regulator back on this one. We're going to need to clean this one first. So we're going to need to get this board cleaned up. We'll check it then for shorts once we've done that. So let's just clean this thing up first and make sure everything here is nice. That also looks like that's moved a touch, so we'll thing it up. That's fine. Okay, we'll then come around here. That all looks good. Yeah, I'm happy with all of that. So that's all fine. So we'll just clean this board up a minute, and then we'll do some short tests on this just to check how this board is as well before we do anything. Let's get that. And then we'll see if we can get any life out of this one. Okay. Bit of hot air. There we go. There we go. Okay. So, let's check that this one isn't shorting out as well, because if this one is, we're boned. And we'll be diving around for a fault. So, ground. Ah, look at that. That's interesting. Should we check a new one? It shouldn't be shorting on the output. That's not good. That's really not good. Right, where's my working one? It's cable tied in. Let me uncable tie my one a minute. That is interesting. We definitely shouldn't be shorted on the output. That's just not normal, but I want to have a look for looking's sake. Okay, so here is a working one. This is my working one. space, my bench testing one. Pardon me. So we'll hold him there. Yeah, no, it should not be a short on the output. It should be, yeah, as open as it goes. There you go. That's fine. So we have 2 shorted VTXs. Very, very interesting. Very interesting indeed. So the first one, this one is shorted. And we removed the cap off him, which I'm going to worry about in a minute. And this one is shorted. Now, as that is the case, we're going to put that one back to one side. And we're going to go back to this first one because there's no point trying to chase a short on 2 boards at the same time. We may as well try and chase it on this one. So the question is the main input shorted? No. Main input is not shorted. We're okay there. But the 5-volt regulator output is not to that cap, not on that cap. I'm just having a poke around now. No. Ooh, both sides of him are short. So that's definitely the 5-volt rail there. That comes into the IE2000. And we're also short in here. What's up, FPV? Thank you, mate. Becomes easier to prepare. Yes, that's the interesting part, isn't it? Choose a match. So, we clearly have something going on. So the best thing we can now do, let's get in close and let's start looking at a proper look at what's going on here. So, what we're going to start doing is just wander around the board. How focused are you guys? You're pretty good, but you're not as good as you could be. Let's get you better. There you go. So what we're just going to do is have a wander around and see if anything stands out that looks off. So a crack on a capacitor or something that just looks wrong. Because sometimes you can see this stuff. Come up here. Now, all looks fine. Up to this end. No, everything looks good. Right, let's flip it over. Now, if I'm a betting man, right, this regulator has me also suspicious. Let me just look at this reg a sec. Is the output on this regulator shorted? Right, we've got multiple outputs here. Now, if I was a suspicious man, I always look at other regulators for issues. I'll tell you why. Okay. So that coil isn't shorted. What about that one? No. Okay. So what I am going to do, I am going to lift that regulator. That is one I just have a suspicion about. I don't know why. I could be wrong. Thermal paste in the bloody MIPI connector. Bloody stuff. Gets everywhere. There's definitely a regulator, and I am suspicious about him. I am just a little suspicious about him. So, we'll pop him off. And I'm guessing it's a regulator. It looks like a regulator. Unless someone's checked the part number. If someone's checked the part number and it's something different. Let's borrow him a minute. And we can always pop him back on. There we go. I don't know why. But I'm just wondering. No, not him. Bit too easy to be true. Ow! Sort. Because what can often happen is this. If one regulator goes down, it drags the other ones with it. That can absolutely happen. Now I'm going to have to put some solder on that and put that back on. There is a few unpopulated things on this board. You might see some unpopulated stuff. I wouldn't worry about it. There is some unpopulated stuff here and there. There we go. Okay. Just put some leaded solder on that. Just so we can get the good stuff on it. Instead of the crap. We'll just pop him back on before it vanishes on me. We don't want it to do that. Let's get that in view for you guys. Let me just come out a little bit. Ooh, lost the focus. Look at that. There we go. One second. Let me just pop that down a minute so I can. At the moment it's floating in mid-air. Let's just float him in. Here we go. That'll do. You should see me doing this with my Parkinson's. It's hilarious. Yeah, not easy, Bruce. Not easy at all, mate. I'm going to say this while we've got a lot of people here. How many people we got here? 92. Hello, 92 of you. I was talking to Bruce yesterday. Was it yesterday, Bruce? We had a chat. I can't remember. We need to do it more often, Bruce. Actually, we need to. We had a quick Skype call just about the last week and all of the bloody nonsense. And yeah, I'll be honest, I'm just a bit fed up of everything at the moment. I've it's been a weird week, and it's all. Whoa, look how hot that is. Look at it boiling off. Ow! So what I'm going to do, while I'm here, I'm going to clean that MIPI connector out. I just want to make sure that there isn't nothing dull going on. Now, the user has said is if I can't repair one of these, he's happy for me to destroy it. So I tell you what we will do is we will be, if we can't fix one of these, be delidding the infamous FPGA. And we will do that. There we go. Okay. But yeah, we had a good chat yesterday. It was nice to catch up with Bruce. It's not something I've done much, but Bruce is just one of the most experienced people in this game. And yeah, it's just been a week that's just knocked me for six a little bit. And it's just been trying to decide what to do with things. You'll notice I haven't put a lot of content out because I've just not got the feeling to do it. And when you feel like that, it just means you're not in the position to do the stuff you'd normally do. Definitely need a thermal camera for diagnosing something like this. Right, we know it's not that cap. The problem I'm at now is I'm at the stage where I'm throwing crap at the wall because I just don't know. There's nothing. I literally would just have to start taking components off the board because there's just no way to tell what it is. I wonder what that is. What is that? The A203L. It's a weird component. What on earth is that? Anyone have any ideas what that is? I'm just going to fully clean this board and get all this thermal compound off. I can understand why people are fed up. Look, I make content to try and put helpful info out there. What I don't want to be is dragged into all of the politics around that. If I say I think something is broken, the manufacturer needs to fix it, it doesn't really need someone else to make a video on that. And whilst I guess that's the territory when you get popular, I don't mind people doing it. I'm not saying I don't want people to highlight the channel and stuff like that, but it all got really weird and messy this week. And look, it's all fine now. You know, everyone's happy, everyone's okay, or no one's happy. That's probably the right position. If no one's happy, then it's probably the right outcome. But yeah, it's just been a weird week, and you just wonder, you know, I don't make content to make money. If I wanted to make money, I wouldn't be doing this. Right, okay, so we've got all the thermal compound off that now. That board is now clean. It was doing my head in. You know, you want people to cover your content. You don't mind. You know, my video is being covered by about 5 different channels, which is crazy, really, which I think is okay. It's great. I appreciate it. I like it. I don't mind people covering the content. The only thing I will say is if you're going to cover the content, please at least say where you've seen it. And look, I got no issues with people agreeing or not agreeing. That's fine. But just, you know, just say, look, this guy has an opinion. I don't agree with it. Let's move on. That's probably the best way of handling it. Right, so I just want to have a look around this board. Now, something that did get very hot was the Dialog chipset earlier, but I'm reluctant to lift that unless I absolutely have to. If I absolutely have to lift it, I will, but it's not going to be easy to put back on. That's a big QFN package. Interesting indeed. So, our circuit comes in. We go 5 volts to here, okay? So let's just have a look at this. What am I using to clean the board? Isopropyl alcohol and a paintbrush. So isopropyl and a paintbrush. It does no harm. You could basically run it underwater in isopropyl. So the power is this. You've got ground, input, output. Output goes into this pad here. Out of this pad here to probably here. And then it'll head off somewhere else in the board. We do have these 3 transistors here. Let's just test for ground on the pins just in case, because they are the sort of things that could, I guess, go down. Seems fine. No, they're fine. There's no short on them. As long as they're doing the same things, I think we'd be fairly confident they're okay. So look, nothing, live, nothing, live, nothing. I think they're probably okay. I could test them separately, but I don't think there's any need to. I bet under there is a P1. I could check on my working board, but I'm just having a poke around at the moment. That there's definitely so that 5-volt rail, right, is coming this way because these caps should not be shorted. That's for sure. Anything showing on these? They should not be shorted like that. That's just not normal. I don't need another VTX to know that's not right. If I grab one, if I grab my spare, I'm gonna have to let me disconnect my UFLs and then we'll pop it down properly then. There we are. This is my working one, this one. So this is a working VTX. So if we just have a look here, you know, if we've got the input there. Okay, so there should be nothing there. It's got a ground. Yeah, that's fine. I'm just looking on this where that is. But you should have ground on one side. So if I come over to these caps over here, which are shorted, you know, on this one, that's fine. That's fine. That is shorted on the other board. Yeah, see, there's definite... You should have one side going down, but not the other. So, yeah, this working board looks good. This, you know, we're seeing what we would expect there. Comfort break. Let's have a look. Oh, that was weird. My internet connection dropped. That was really weird. That was strange. I lost my internet connection. I looked across and it just went boom, all off. That's weird. Okay, let's carry on. Sorry about that, guys. That's weird. Right, okay. Let's go for it. What we'll do, we're going to wire it back up and we're going to pump some proper voltage in. We'll go for bust on this one because, well, we can. So what we'll do now is we'll wire him back up and then we'll pump in something like as much. We'll go for it. Okay, there's one. Let me just get the other wire. We'll go for this one. We really will. There, cool. So let's come out. Woohoo! So let's power the power supply back on. Right, there's 4 amp going in now. Something's going to get very hot. At 4 amp, right, something is going to get very hot. That I can promise you. Something is going to be cooking. I reckon it's that IC. 90%. It's that Diagnostic IC. Look at that. That's crazy. It's boiling in. Oh, you guys can't see that. Sorry, let me show you that again. It's that IC. Watch this. Ready? Let me just focus. So watch this. It's boiling the isopropyl alcohol instantly. That's at maximum zoom out at the moment, unfortunately. I am 99% it is that. And our wire has now come off. So, I think we will we'll get him off. I think that's a safe bet. And then we'll see if the short vanishes. That is a system management voltage IC, I believe. So it does make sense that it would fail. Quite a big one as well. So it's probably the 5 volt is taking it out. The only problem is I suspect the other one's got the same problem. Oh, he's got a big pad. Oh, look at him. That thing's got a lot of heat soak area, hasn't it? Look at that. Right, let's get some fan running. We definitely want some cooling on that now. Let's get the fan running on him. Salmon Rose, this one is this is an SMD workstation heat gun. It is a good way. What you've got to be careful of when you're doing that voltage thing, what you've got to be careful of, yeah, that pad will definitely be ground, is you can't exceed the voltage that the circuit would normally have. But you've also got to take into account that if the component you're testing is shorted, is passing through, it could pass that voltage onto other ICs. So you always want to make sure you keep the voltage low and the current high. So maybe 1.5, 2 volts. You don't want to be going over that. If you're doing laptop repair, no more than like 1.5, 1.6 volts. Because a lot of the time you can have a shorted FET on the CPU power rail, which is designed to supply like 0.9 volt, 1.5, 1.8. And by pumping in any more than that, you can actually blow it. So you've got to be very, very careful. You've got to be very, very careful. There we go. That's cool enough to touch. Shut up. It's my fan. Right. So we should, all being well, have lost the short. Now, so where are we? I've lost where I was. Where's the voltage regulator gone? There, it's in front of me. Okay, so we're gonna touch there, and there we go. Let me just go to the overhead. There we go, guys. The short is gone. Beep, beep. Gone, 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 gone. So, that system management IC is the fault. For the guys who asked, would that center pad be ground? I would expect it to be. Yep, there you go. Definitely. So, she's a goner. She is a goner. Now, it is replaceable. It's not one I'd want to do, but it is doable. But we'd have to figure out what it is first of all and have a look at costings. So it's a Dialog DA9062. Dialog DA90. Let's have a look, shall we? Go back to the desktop. DA9062, I think it was it? DA9062, there we go. DA9062. On Mouser. 3,000 in stock, £3.78. It's not an expensive component, but it won't be an easy one to change. No, we want the data sheet. Should we have a look at what it is? I suspect, I think it's a power management IC. To me, it looks like a power management IC. There you go, power management integrated circuit. It just smelt of a power management IC because of all of the coils around it. 4 buck converters. So, it's got a 0.3 to 1.57 outputs, 4 of them. Similar to what DJI actually use on the Vista. Now, that is going to be the IC. Okay, so if we go back to the scope, that is going to be the IC that is providing the system management power to the main chipset, you know, the VTX Xilinx FPGA. Unbelievable. But it will also be providing the voltage for the SRAM and the other components on the board. Now, what I suspect is happening, and I suspect the other one is exactly the same, is that this regulator pops. This is going to be supplying 5 volt to that system management IC, and it's taking that out as well. That is what I would suspect. Now, the problem here is that whilst this is replaceable, this regulator isn't available. We cannot get this one at this time. So at this moment, it's not an FPGA, it's lies. It's mislabeled. For those who don't know, it's not actually an FPGA. It's complete bullshit, and it is nonsense, and it's mislabeled. Now, whilst we can get one of them, we can't get one of them, which is a big shame. We also have the same problem on this board. This board also has a short. Now, if we check this one again, we've also got a short on the input. And again, if I'm a betting man, I'm going to bet it's the same problem, and it's been the system management IC. Let's just clean that up a second and see if we can see anything. Scavenge one. Well, we don't have one to... I only have one regulator here. They're not common. They're made by a strange Chinese manufacturer, which we can't get a mold of. Just wiring an external 5 volt back. Yeah, Bruce, that's probably their only bloody option, I'll be honest with you. I don't think you're wrong. I think you are absolutely bang on. Yeah. Let's get this clean up and let's have a look at what's going on here and see in there. Just going to clean up around here a minute. Put a bit of heat on it. And I think what we now need to do is the same test on this one. We'll wire in our back wire a minute, and I think we'll check our power wire, and we'll check if it's the same issue, because if it is, that means both of them have killed the system management ICs. If I'm a betting man, it is the same issue. If I was going to put money on this right now, the money would be that it's the same problem on both. There we go. I've wired me wire on. And we'll do the same test again. Let's just make sure that's not touching the ground. No, that's fine. Take the lid off. What we need to then do is change the output on our power supply. We want to be down to like 1 volt. There we go. We're putting 4 amp in. Again. Oh, shock horror, look. There you go. Instantly. They're boiling the IPA off. Interesting, it's also boiling elsewhere on the board now. So if we just put a chunk on a minute. Oh, yes. So, again, another blown system management IC. Let's get it off and let's see if the short goes away. Just to confirm. Someone said don't torture it. I don't have a flare, unfortunately, no, but we sort of know where we're heading now. Here we go. What I'm going to just do is pop that back onto there. And we'll do our quick test. Yeah, short gone. Instant. So the issue is definitely those system management ICs. 2 dead VTXs, 2 dead system management ICs, and main 5-volt BECs. This is probably going to be a common issue on these VTXs. I suspect that is what we'll see if we see these dying moving forward. If I'm a betting man, I think what we'd have is the 5-volt reg getting nuked and that taking out the system management IC. It is possible the system management IC is what's wiping out the 5-volt reg, the other way around. That's a possibility as well. But yeah, interesting. Now, I'm going to speak to the owner of these boards before I do anything and find out what he wants to do. Repair is possible. You know, what are they? £4 a chip. Is it the 1S? No, these are not the 1Ss. These are the standard ones. These are the standard boards. Are they repairable? Yes. We'd have to have one of those system management ICs. It's not going to be the easiest component in the world to change. If you just look at the type of product component it is. It's doable though, absolutely. You could replace the system management IC and then try to replace the 5-volt back and see how it goes. It's a question mark of, is it worth spending all of that money to not know if we can get it right? And really that's where things get to then. There's nothing I can take from one to the other because it's the same problem on both VTXs, unfortunately. The 5-volt regs are impossible to get right now, so we'd have to wire in an external back. Northern Tier FPV, wonder if the HDZero boards have the same management. No, they don't use a system management chip. They use multiple regulators. So HDZero do it a bit differently. In fact, there's a HDZero board on the bench. Let me just go to you. So, just to show you this is a HDZero board here. And this is a user's one I've been looking at. And they do still have a 5-volt back. So what they have is their 5-volt back is down here on the input, down this side. So you've got some diodes, capacitor, 5-volt input and coil. Then they use other back regulators. So you have a regulator up here. This one is a dual regulator. These are coils. So you've got 3.3 and 1.2 volt off that one. You've then got another regulator down here on the board down here. No, not that one. Where is it? That's part of the regulation there. There is another one somewhere. Now, part of the reason they're likely not using system management ICs is there's no RAM on here. There's no SRAM. There's no DRAM. There's no RAM of any sort on the HDZero board. So the DiviMath chipsets can be made to run off much simpler voltages. Whereas the Avatar is the same as DJI, and they have to use a system management IC. Now, the DJI boards do have a system management IC, but it's a different one. If we go to the desktop and go to repair.wiki and go into drones, and if we go to, where are we? Air units. Okay. So DJI do have a system management IC, which is this one here. So the MPSJ46 or the MP5416. And what DJI have is you have a 5-volt and a 3.3 volt regulator. So 3.3 volt here and 5 volt here. And they're using 54335As. We've got a regulator here and a regulator here. And then this is the system management regulator with 4 coils, 1, 2, 3, 4. So you've got 0.9 and different voltages coming off this side here. So whilst they do use a similar setup, they use a different system management regulator IC. They use the same regulators here. They just are slightly different for this compared to the other ones. And if I go back, if I go down to here, you can see here, I've actually labeled up some of the voltages here on the regulators. So you've got the 5 volt, the 3.3, and then the system management, and then you've got like 0.9, etc. all around. So DJI does do this, similar on the Vista again. You can see on the Vista there, it's exactly the same, but it's a different chipset. It's just not the same chipset at all. Sorry, let me get back on camera view. Where am I? Yes, so that's it. That's the situation. So we now have a bit of a better understanding of what is causing the problems. Now I need to speak to the user. I think both of these are dead. I'm not convinced it's worth. I say I'm not convinced it's worth. Sorry, it's been a long day. $10 in components is worth fixing a board. but it's whether we can get those 5-volt regs as well. That's the complicating factor here. DJI see better quality? No, that looks a logic. It doesn't look bad, just different. I suspect filtering is probably the issue. DJI do things a bit differently. DJI have a big FET on the power input to control it, which these don't. And that FET does take a lot of the hassle. It does stop the board getting as hit. It really does. I can't stop yawning now. Once you start, you can't stop, isn't it? It's a nightmare. Fly High FPV, how are you, my friend? Hope you are well. So, that's it. We have 2 damaged avatar. I keep saying avatar VTXs, both with the same issue. Now I'm going to talk to the owner and find out what he wants me to do, because I would love to delid one of these. So keep an eye on that. That's something we might do in the very near future. Anyway, guys, that's it from me. I want to say thank you for the super chat the person gave. I really do appreciate it. Thank you all for spending your time with me. Just a little bit of a random live stream. Stay safe, and I will speak to you soon. Now I've got to try and find out how I end this. There we go. Cool. See you later.